important things to like remind you and remind myself is that this class is an experiment. This is the 4th time I've taught this class. Every class it changes a little bit. So it's also based on your input that will change. There are 9 students this semester, course, whatever. That means each of you has like a pretty strong influence on how I teach the class. So this week I'm going to show you like some inspirational materials. If there's something you're really interested in learning that isn't currently in my list of things to learn, please let me know. I'm very happy to either change some of the class materials to cover it, or to record a video and just post it to YouTube and let you watch it. Like, quite honestly, I have spent the past 7 or 8 months since I started teaching this just recording videos over and over again for these materials and adding to that library. So like there are a lot of materials online, and I would even say like the first time I taught this class, there's material there that I won't cover in this class. So it might be valuable to like go back and like quickly watch some of those videos and skip through like, yep, I heard this part from Derek before, but here's something new. So there is like, it's a 5-week class, which is pretty short. So there's a lot of other material, and I'm also happy to like provide other things. The thing I really want you to get out of this class is a couple of things. So one, I think I said this earlier, but I want everyone to make stuff. Like I find that the way to learn this is to not to read about it, but to actually do it. So many of you have probably read stuff about machine learning and been like, that's great, I still don't have any idea how to actually do this. So this class will be about you learning how to do it. The best way to learn it is to actually just do it. But I also recognize that everyone has different like sort of job duties throughout the week. I'll talk a little bit about like ways to approach this class. I do have homework assignments. Those homework assignments are all optional because I recognize everyone has a job or everyone has a life outside of this class, and you may not have planned to like spend time doing homework. But I would say if you can do the homeworks those weeks, you should, because that's how you're going to learn a lot about this stuff. So again, I'll talk a little bit more about this in a minute. So this class is really about image making, and it's not about machine learning as a theory. So I will cover as basic of concepts of machine learning as possible, so you can get like an idea of what's going on, but like I won't get into like the really deep stuff. And that's on purpose because one, this class would be like 20 weeks long if I taught all that stuff. And two, it honestly doesn't really matter that much to you making things. I think there's like this idea that you have to understand how machine learning works in order to use it. And it's like, we don't ask people to understand how HTTP works to use the internet or to make a website, right? So like, I try to teach as little machine learning theory as possible in this class, but I also recognize that you kind of want to know what's going on anyway. So I do try to teach a little bit of what's actually going on. But for the most part, it's going to be about you making it. And like, when you fail, then you'll try to figure out how or why you failed. And that way you'll learn about machine learning. And the last thing, I probably won't get to this like the very last week or so, but like you might just learn as you watch me sort of walk through things. This is a 5-week class. At the end of the 5 weeks, you're gonna be on your own, or like you can jump in my Slack channel and ask stuff when you want to, but for the most part, you're gonna be on your own. And this field changes every 6 months. So there will always be new stuff coming out. So I'm gonna try to talk a little bit about how you can actually keep learning this and how to explore new models and how to learn about new things as you go on. Just because realistically, I can't expect you to like learn everything out of this class. So we'll talk a little bit about that. So here's the schedule for the next 5 weeks. So this week we're gonna go through a bunch of inspiration. We're just gonna show you a bunch of machine learning art, mostly images and videos, because that's mostly what we produce in this class. Depending on how much time we have left, we'll go through some setup stuff. If we don't get to anything, that's fine, because we can always do it next week. The one thing I do want everybody to have done before they leave this class is that you have a Paperspace account. You don't necessarily have to have a server set up through them, but I need you to have an account so that I can get you whitelisted for the servers that they will provide you. So please, before you leave, I know Yadam, you said we're having issues. So if anyone else has issues, let's make sure you get an account before you leave so I can make sure you get processed. So for next week, we're set up. Week 2, we're gonna talk about data sets. Data sets are the most important thing in machine learning, especially in machine learning art. We're going to learn about how to make them, how to understand what data sets you need for what models, like those sort of things. So we'll do a big deep dive into data sets. That is like the most important part of the class. So if you have to miss a week, do not miss next week, please. And And then for the week 3 through 5, it's going to mostly be we're going to look at different models. And this is sort of up to you as a class, what models you want to work on. And I'll show a bunch of different models this week, and we can look at them, and you can tell me what you want to work on. Week 3, we'll probably do StyleGAN. StyleGAN tends to be the most popular model that everyone wants to learn. So I just teach it. It's also one of the harder ones. So I teach it early, so you have a lot of time to like learn through things and like understand stuff and work with me on it. The reason it's the hardest is it needs the biggest data set. So it's going to take you time to build that data set. And we'll talk again about that over the next couple weeks. The last class, I also taught style transfer and next frame prediction. Again, I'll show examples of those. I can't expect you to understand, like, yes, this is what I want to learn until I show examples. Style transfer happens to be like a really like simple, like straightforward thing. It's essentially free now to do it. So it's like, that's also a nice side benefit. And then people like next frame prediction because it's super weird. It's weird and it makes trippy videos. So I tend to treat that. Other things we can look at are a thing called CycleGAN and Munit. I have some examples of that. There's also a thing called SynGAN, which I think I removed from the slide deck, but is also worth showing. I might show some other examples of that, like in Slack or something. I generally do the last class for a working session. If we have some overflow from this stuff, we'll do that. But that sort of is like one-on-one time with me. And then if people want to show off what they've made over class, they can. But I've just found that like I will throw a lot of stuff at you over the first 4 weeks, and the last week you're going to have a ton of questions and or be in the middle of a project and want my help. So that's generally how it works. Week 5, let's sort of see how we get, but generally that can also be an optional class. So if like you can't make it or you're sick of coming to the Lower East Side, you can like decide to do that one from home or something. So yeah. Okay, so approaches to this class. So as I said, like every one of you has a different either 9 to 5 or 9 to 12 or whatever like your life outside of this class is. So I understand that people have different expectations. There's sort of a couple different approaches. So if you're really hardcore and you really, really want to learn this stuff in the next 5 weeks, follow along each week, show up each week, pay attention in class, obviously, and do every homework assignment. Students have told me that that equals to about 10 hours a week. So that's a lot of work. I'm aware of that. It is a lot of work. I'll just say that. Like if you actually want to catch up in 10 weeks or in 5 weeks, it will be a lot of work. So not everyone can do this. Some people have started doing it and then they fall off. It just happens. The second approach is to follow along each week and think of one project to work on. So maybe this week you get inspired by something you see and you say, I want to make something just like that. And you should basically let me know because I could always send you materials ahead of time. So let's say you really want to do style transfer and you want to do style transfer video, which takes a long time to process. If you let me know like, hey, that's something I really want to work on, I already have a video on YouTube on the steps and how to do it, and I can just send it to you and you can start working on it. So it is worthwhile to think about like in the next week or two what you want to work on, because that's sort of a good approach. I think this is a helpful approach because if you know you want to do StyleGAN, know that it's going to take you a lot of time. So therefore, like start to plan ahead about like the steps you need to do for the class. Your third approach, which I don't recommend, but you're more than welcome to do it, which is just show up for this class, attend the lectures, don't make anything. I think you won't learn as much, but I also recognize that people have schedules, and like I know I've had a couple students over the past who've just been like, I just got really slammed at work and I just can't work on this, but I'm really excited I was a part of the class and now I know where to keep learning. So it's a possibility. You're not being graded. This isn't a class like that. You're just here to learn, so you learn what you want to learn. Any questions before I jump into work?
Is this slideshow like available to you?
Yes, yeah. So all these slides are on Google Drive, and I'll share them in the Slack after class. So basically, like either at the end of class or first thing tomorrow morning, you'll get like the YouTube video link, and you'll get my slides, and then you're also welcome to start posting questions and stuff in Slack. Actually, that's a good point. Let me really quickly jump to the Slack channel, and just sort of talk about like how it's used or how other people have used it in the past. So I think everyone's in the Slack channel by now. If you're not, please try to make sure you are by like tomorrow, because that's when I'm going to start posting announcements. I don't really like use email that much, so I mostly will post stuff here. So you'll see here SSHH3, that is like our channel. A couple other people have joined it just because I think they're interested in seeing how it works. If people get too talkative that aren't a part of this class, I'll ask them to leave or I'll kick them out. It's my Slack. I can do whatever I want. But this is for us. So this is like I'll post lecture notes, other things in there. You should feel free to post any and all questions you have in here. Like basically for the next 5 weeks, I will try to prioritize responding to you guys rather than anyone else from my classes or like previous classes or just people in the Slack. I'll generally also try to respond like within 24 hours. I can usually do that. It just depends on how busy my day is, depends on the questions you ask, like those sort of things. But I'll generally get back to you pretty quickly in there. But this is where you should also feel free to post work, like things you're making, questions you have, things you're thinking about making and just don't know if you can do it. Like this is your space. There are other places within these channels that you're welcome to like post in. I think each of them is sort of labeled in a way that I hope makes sense. Like if you have questions about machine learning, you can ask them in here. Like if you have questions directly about StyleGAN, you can post them here. In general, I find most of my classes tend to post just in this channel, and that's totally fine. If you want to, you can check out RC2_1 is the class that I just recently finished. This was an entirely remote class, so they were super using Slack all the time. They posted a lot of cool work. It will probably be like trying to follow the thread will be insane. So like just scroll through it and look at the work that people made, because I think that's the coolest part of it. You'll also see that there are other slides in here. There's us talking about things. You might get some answers in there. It's a cool place to check out, but it's like clearly not something you can follow or read. So yeah. So generally like it's also it's up to each class. Like I've said, like SSHH classes tend not to use Slack as much because we have a meeting time. So people will just generally wait until I show up and they ask questions here. But like if you use Slack, I will be really happy. But it's up to you. The YouTube channel is Busbright, and if you come in here, you'll see a ton of videos. They are haphazardly put in playlists, so you'll probably have to dig around a little bit. If you have a question, just ask me about can I find something that does this. This was again this last class that I just taught. There's a ton of videos in there. Me and my teaching assistant sort of broke them up in different ways to see how people would use them. So it's kind of chaotic, but there's a ton of stuff in there. Machine learning demos is just stuff of me demoing different tools. So this is probably like a really good resource for you guys to check out. Most of this will be overlap of what I teach every week, but in here you'll find lots of like interesting demos of actually making stuff. A bunch of my own work is uploaded here as well. You're welcome to like hop in and just like look at something and then ask me how I made it. This is one of the pieces I made, and I think someone like already today was like, hey, how did you make this? People will usually ask me for tutorials on how I make stuff, and I'm just sort of like, it happens as needed. Generally what you guys ask me for, I will produce videos more frequently, especially for the next 5 weeks, than some random person on the internet. So yeah, so like if you guys have questions, please let me know. Probably in Slack, that's probably the best place to ask. And I will like usually try to produce videos for you guys ahead of time before class starts. So Slack, YouTube, you have my email address, feel free to use it. But in general, these are all the materials for class. Let me jump back to slides. So I started showing one of the pieces that I worked on, but I'll talk a little bit about myself. So I'm a product designer actually by trade as well. I think, Taylor, did we overlap a little bit? Yeah, a little bit. Okay. So I worked at the New York Times for a little while. I'm now at MailChimp. This just happened to be like a side hustle that I was interested in. It sort of has grown into like a practice amongst other things. I think one of the reasons why I'm good at teaching this is because about 2 years ago, I was in your shoes. I was really interested in machine learning. I didn't know anything about how to actually use it. I took a class over at SFPC. I don't know if you guys know them. They had a 1 week intensive machine learning session. All of these great people were teaching. I recommend you look up every one of these people because they're all really awesome and they all do different things. So if you know Zach's work, Zach's a very like interesting visual designer. But then you have people like Caroline, who is like a critical theorist, and she talks a lot about machine learning, but she's also a designer, so she sort of approaches things critically. But anyway, all these people are worth looking up. I was handed all this material in a week. Like I literally went over there, and from like 6 to 10 every night, I learned a new thing. It was super overwhelming. I learned a lot, and then I didn't touch it for 6 months because I was so overwhelmed. So you might find the same with this class. 6 months later, I picked it up again, started learning, realized these resources like weren't really out there. I knew a little bit just through like Gene and some other things, and I just started like finding things out myself. So I'm very much teaching from your perspective, just like 2 years ahead of you. So I totally understand when people are like, I read all this stuff, but I still don't understand how to make any of this. And that's like, the point of this class is like, I'm going to teach you how to make stuff. This is really early work of mine. So this thing on the left is a very early GAN, where you could only produce stuff at like 128 by 128, and like to blow it up, it just creates this weird collage. The thing on the right is actually a style transfer, and I would say it's really bad. Looking at it now, I've learned way more about all this stuff, but like this was my early work. So like, don't feel like you have to make amazing stuff like right out the bat. You will definitely make more amazing stuff than this right out of the bat, I hope, but we'll see. I have started like turning this into some of my illustration work as well. So the image on the right, on the far right, is a style transfer that went through like a number of steps, including some Photoshop work, and was produced for the baffler. So like, I think some of you have said like I'm really interested in like taking this and not just like turning it into machine learning work, but like building it into other things. So this is also another. This is from the same article for the baffler I did, which is like taking some machine learning work, bringing it into Photoshop, doing some other work with it, and doing illustrations out of that. So definitely like we're all on the same wavelength, which is like the end of machine learning is not just the output. It's like you can do more with it as materials. Okay, cool. So we're gonna do a quick demo. So I want everyone to write down a sentence, or like think of a sentence in your head, and then maybe if you can, post them to the Slack channel. Well, I get set up here.
Is there Wi-Fi here?
There is, yeah, it's right here.
Oh.
So this is the network, and then this is the password. Cool. So in just a minute, try to post your sentence into Slack.
I'm downloading Slack for the first time.
Okay, that's cool. Do you just want to tell me your sentence?
Sure. I'll do a poem one. Yeah. The absence of the wish does not invalidate the spell.
Absence of the wish does not invalidate the spell.
The witch.
Witch.
Yeah,
Witch.
I think it's
Not Harry Potter.
Oh no. Minus 10 points for Gryffindor for that one.
Okay. Did everyone get their sentence in? Cool. All right, so we're going to look at a model that makes images from sentences. So I'm going to take these sentences and I'm going to stick them in our model, and I'm going to see what it makes. So I'm going to take Joshy's for the first one. The shirts for sale at SSHH are very bright. That is a factual sentence. And let's see what happens.
Whoa.
Okay, so we have a sentence, we have an image. I'm gonna download this image. We'll do a whole runway demo in a minute, but like I'm just gonna quickly show you how this works. So I'm just gonna save this. Yeah, thank you. We should have done that from the beginning. The other funny thing is if you've never been in this space before, people will walk by and like someone will stop for like a good 20 minutes and just watch me like present. It's super weird. And you're kind of just like, you kind of like stare at them until they like make eye contact with you, and then they realize it's weird, and then they walk away. So it's fun. Okay, so that was Joshy's. I'm gonna take Nyons. Is that how you pronounce it? Cool. All right, awesome. So I'm gonna take Nyons and paste that in here. The rabbit cried in the corner.
Wow.
Rabbit.
As somber as
That's
the
amazing.
sentence.
All right. I'm sorry. What was your name again?
Luis.
Okay, I'm gonna take yours. So I'm gonna paste in here. So I'm not gonna get to everybody's, obviously, but whoa, that's interesting. Okay, so we tried those 3. So I'm gonna put in another one, which is one of the ones that I always use, which is the dog chased a ball at the beach. Okay. So I'm interested, what did people think about that?
It's cool.
It's cool.
It's random.
It's random. Say more.
What happened if you use a paragraph of text? It will change more or?
I don't know. Let's find a paragraph. What's a good like text generator,
Laura Mipson?
or just like a paragraph generator? Let me just see. Paragraph.
How about
Yeah,
voiceover.
Wikipedia, that
It's
was
start
article
Ipsen,
today,
it's
yeah.
fun.
But I mean, does whatever tool you're using definitely gets the meaning from the word, right? Do they understand Latin?
It does. This definitely does not understand Latin.
Yeah.
All right, I'm gonna get into deep areas here. Okay, so anyway, I won't actually do that, but that'd be a cool example to try. So you were saying it looks random. What do other people feel like? What do you think is being random? Like, or I guess like maybe let's put it this way: what do you think is being done with this model?
Looks like keywords are being pulled out,
Yeah.
and there's something being averaged there. Like it looks like, as you were typing this sentence out, I think that was the most realizing example because we were able to kind of see the sentence develop. It was kind of vague dog-like animal parts up until you put beach in the sentence, and then now we have this very beach-like gradient that's the background of the
Yep.
image.
Yeah, I think the texture is what was standing out to me because the texture feels right.
So the way this model works is just how we sort of described it. It looks for keywords, right? So the way it's built is actually it's reverse engineered. You take an image, then you give it a sentence, and you sort of like feed thousands of images and thousands of sentences to a machine. And it sort of learns like what is the image tied to the word, right? So like if you feed it a lot of dog images and you say dog all the time, it learns that like, hey, something in this image refers to a dog. How like of all these images can I find lots of dogs in these images to match up? So there's a couple things to learn about this model. First is that this thing sucks, right? It didn't actually generate good images. Or like it generated interesting images, but it didn't generate realistic images. And that's one of the common things that you hear about machine learning, right? Is like machine learning is going to be the future. It's going to change everything. And it's like, if this is the future, this sucks. Like this isn't like, this is really interesting imagery, but it's not like actually doing what you expect it to do. So we're going to find that over and over and over again, that like machine learning is not as smart as we all think it is, or as we're told it is. The other thing to know from this is that just like Joshy said, it like knows words. And the reason it knows some of the words that I used here is because I know what this model was trained on. So I know what images it was trained on. I know like what it knows and what it doesn't know. And that's a really key part of machine learning too, is that the data you train it on influences what its outputs are. So when we put in Luis's sentence, which like had no words that like are like, I guess maybe witch has like we could just type in witch and see what happens. But like that's what it sees as a witch. Like that's not like remotely what we see as a witch. And that probably means it just wasn't a part of the training data, right? So if you put in a sentence that it doesn't know anything about, it like will kind of try its best, but it won't really know. Whereas like when I typed in dog, like it's not the best, but like what was it? A dog chased the ball. Like you can actually see like there's a dog leg there. There's kind of a dog face. Like maybe when it learns about balls, it sees a human throwing the ball or something. Yeah.
But you typoed, which is not a call out. You're
Yeah.
saying like does the algo recognize
Oh,
that you typoed? And,
interesting.
Like, if you
Oh, there you go, better. So yes, it probably does. Or it probably like screwed up because it didn't, because I had a typo there. So that's part of it too, right? Is like if I feed it incorrect information, it doesn't predict anything, right?
Yeah.
These things aren't that smart. Like these things know enough to like be able to generate a weird looking dog and a ball and grass. Like that's about it. So these are things that I think are really important to learn about machine learning and things we're going to learn over and over and over again in this class. Just like it doesn't produce like really accurate stuff like you expect it to. It requires so much training data, and also that training data is very specific. Any other questions?
How long did it take you to do whatever this is?
I didn't. So okay, yeah. So like, there's a thing called training, and there's a thing called inference, which is what I'm doing here. So someone else made this model, and they trained it, and they put it up on this thing called Runway, which we'll look at a little bit later. So this was literally like what you saw me do is what it takes me to do this. Runway is a system that we'll play with a little bit, especially this week. You can download it, you can run it. It costs 5 cents a minute. Yes, 5 cents a minute. You get $10 in free credits when you sign up. I have a $10 coupon for everyone as well. But while it's running, you see this little like red button here that says stop. This is running, it's charging me money. That's because it has to run on a GPU. We'll talk about GPUs next week. But basically, like Runway is a really simple way to test out a ton of different models. And that's what we'll look at the end of class. But yeah, so the time it took the other person to train this model is probably a month or weeks. And that's not even including the time it probably took them to build the data set. That probably took them a month or 2 or 3 months, and there's probably some poor intern in a science lab that had to like take an image, write a sentence about it, take an image, write a sentence about it.
And that's like the best that we got from that work.
It's the best we got from that work, although I will actually say there is a model of this that is trained entirely on birds that is really, really good. And that's because all birds are pretty much the same shape, right? But if I say robin or bluebird, all it has to learn is what color the bird needs to be. So again, that's also really important to know, is like how different is the model that I'm training it on. And you will find that like if you keep, we'll talk about this a lot, but it's called diversity. If your data set isn't super diverse, but it's like a Goldilocks thing. It's like if it's too diverse, it's gonna be weird. If it's not diverse enough, it's gonna like basically just generate the same image over and over again. But if you find that sweet spot, it's really, really good.
When I think of like data sets, I think of like numbers, but you're talking about like images.
Yeah, so this class is about data sets as images.
Okay.
So images are like basically if you just imagine a folder of 1,000 images, that's a data set.
Gotcha.
And basically what machine learning models do is they convert that. I'll talk about that a little bit, but like they convert it to numbers. Were you gonna say something?
No,
Okay, cool, yeah. Great. Cool. So I'll actually like talk a little bit about this now. So yeah, so like I said, we're gonna talk a little bit about machine learning. We're not gonna go too deep. It's gonna be high level. I've got some other resources if people are interested, but we'll talk just basic level stuff. So most people think about machine learning, they think about this. They think about machines that are gonna take over the world. They're gonna kill us all, or they're just gonna be super smart and we're all gonna be lazy as hell after they're like generated or whatever, right? This is what's called general AI. It's robots, it's supercomputers, it's all bullshit. Like, basically most people who work in machine learning today, except like for the people who have drank the Kool-Aid, like no one thinks this is actually gonna happen. It is way too hard of a problem to solve. As you saw, we can't even get a machine to generate images from words. So like, when is this gonna happen? So like, the people who drink the Kool-Aid every year tell you that we're 20 years off from having robots. We're 20 years off from, it's like they were saying that in the 50s, that we're 20 years off from having robots. It's not the same. It probably won't happen. What we're gonna look at in this class is what's called narrow AI or machine learning. And that's code that does one thing really well. So everything, when I talk about a model, I'm essentially talking about a machine that does one thing well. And that's pretty much like all machine learning is right now. And if you see something that's a really complicated system, it's likely just chaining a couple of these models together, right? So if I do one thing really well, like I get out of bed, like that's one thing. Like walking to the bathroom is another thing. Actually using the bathroom is yet another tool. So like it's basically just chaining all these things together. And that's essentially like when you see someone talk about the future of AI or like we built like a crazy robot, it's just a bunch of different models and they all like run from the same location, right? So if you've heard of like IBM Watson, which is like the supercomputer that IBM has. It's just a bunch of different models running on the same machine or running in the same place and maybe being able to talk to each other. But it's not like artificial intelligence like we would think about it from a science fiction perspective.
To your point, as far as I understand it, Watson was a complete commercial failure, right?
Yeah, it was, but like beyond being gimmicky, it's like its own thing.
Right.
Okay, so one example of a model that does something really well. Here's a model that converts horses to zebras.
Wow.
And you could say it doesn't even necessarily do it that well, because if you look at the the lines, like the fence, it also picks it up, right? But this is actually a 3 or 4 year old model now. This is a thing called CycleGAN. I'll talk about it a little bit. But this does one thing well. You give it a picture of a horse, and it gives you a zebra. And luckily with CycleGAN, you also get the reverse. You can give it a zebra, and it'll give you a horse. That's it. That's all this model does. Now it's built on an architecture or a network. So when I talk about a model, that generally is like the thing, like what do you give it and what does it give you? When I talk about a network, which is what I'll talk about with some of the like architectures, that's like how is it built? So CycleGAN, for instance, takes basically you train it on 2 sets of images and it learns how to convert from one image set to another image set. So in this case, you give it a picture, you give it a bunch of horses, you give it a bunch of zebras, and it learns how to convert the 2. That's a network. That's a way. That's an architecture. That's a system it's built to do that. So I give it apples, and it can convert to oranges.
When you say a bunch of images, how many images?
Yeah, so we'll talk about this. So CycleGAN is like 200 to 250 images. The more images it has, the better it's probably going to learn. I think this is trained on about 1,200 images for each category. But it's hit or miss. Again, this gets to that diversity thing, which we talk about a little bit more next week. Of just like, if I only have 20 horses and 20 zebras, that's probably better than giving it like 20 horses and camels and 20 zebras and hippos. Like this is gonna be messy. So you have to think about like what's the sweet spot, and some of that just comes from trial and error. Okay, so we're also so there's 2 types of networks or models. One is called discriminative model. That is what is called classifier. This is what most of machine learning is right now. It determines, is this category A, is it category B, or is it category A through Z? So that would basically be like, I give a model an image of a dog or a cat, and it guesses whether it's a dog or a cat. This is like 95% of machine learning today. And it's what like most like finance software is built around, because it's all about sticking stuff in categories. Which then you can take that category and say like, this person deserves a home, this person doesn't, that sort of stuff.
I don't do that. Just putting that out there.
Totally fair. So the thing that we're going to work on in this class is called a generative model. And generative obviously means that it makes stuff, right? So it generates images, or it generates sounds, or it generates new data from other data. So everything we're going to work on in this class will be about generative models. I'll talk a little bit about how classifiers work, because that can sometimes help you understand how a generative model works. But these are the 2 things. If people I always find that someone takes a machine learning class and they meet like a data scientist or someone else, and they get like quizzed on like, oh, how much do you actually know about machine learning? It's like one of these things where like, it's just people who are like, no, you don't actually know about machine learning, right? And it's like, I'm teaching that class in a certain way too. But yeah, so if people ask you like, oh, what did you work on? You're gonna say, I worked on generative modeling. And they'll be like, oh, that's cool. You actually know what that is. And now you do. So I actually recorded I think the first time I taught this class was like the first hour was all about terminology, and it turns out that's just a really dumb way to learn this class. So there are more videos and more stuff here if you want to learn more about this stuff. But that's sort of it for like how deep we go into like terminology. So how does machine learning actually work? How many of you took math in like 7th or 8th grade and had to draw a line through this? Yeah, so you might remember that, but it's basically like, here's a bunch of dots, try to draw the line that best fits that model. There it is. This is basically machine learning. It's just on a much more complicated, complex scale. So you'll hear me talk about StyleGAN and talk about how many dimensions it is. So this is obviously 2 dimensions. StyleGAN is 512 dimensions, which basically means it's like 3D but really, really complicated. Our brains can't can't actually process anything outside of 4D, so it's like not even worth trying. But basically, like you just do this, and there's like a ton of other dimensions, and that's really how it works. So like literally, you go from here. There's some other stuff that happens here, and then you have a weird image. Like that's really like the level at which you need to know here. What are these dots? These dots are representative data, right? So we talk about data sets. So like each one of these dots is a point in data. So like when we talk about images, essentially what these models are doing is these models are mapping images to essentially like you could think about it as a 2D plane. It doesn't really work that way. It's like higher dimension than that. But essentially, if I take an image of a cat and I put all the cat images, like let's just say, I'm gonna like, so like let me just put an image of a cat here and an image of a dog here, and then I'm gonna put more dog photos here and more cat photos here, and then I'm gonna say, hey, randomly guess what a photo here is, and like the machine learning model kind of just learns like, okay, dogs go over here, cats go over here, this is a cat, right? And that's like, it's way more complicated than that, but it's also as simple as that, essentially. It's a joke I try to tell all the time, and it just never lands, so I'm just going to skip it. Okay, so the other terminology you might hear or need to know about is a thing called deep learning. Deep learning, they make it sound really complicated, but all it really means is that your network is a bunch of layers. So this is like really simple, right? Like there's stuff here, you sort of learn it. Like this is a very like, there isn't a lot to learn here. Deep learning just adds layers, and the layers are essentially like depth or complexity. So this is an example of a classifier trying to classify a dog. And the way a machine learning model works is the first thing it does is it takes all the pixels and it brings all the pixels into the model. The next thing it tries to do is it tries to define edges. So maybe like it catches the back of the dog or it catches the leg. It then starts to combine these edges together into what we call features. So that might be something like, you know, I've got a little bit of this leg and then a really short horizontal line. So long vertical and a short horizontal. And then it combines those into features. So like this long horizontal and this long vertical and short horizontal plus this short horizontal and long vertical is a leg. That's literally how it works. And once it has figured out all the features, so basically what you do in a classifier is you feed it images. You say this is a dog, this is a cat, this is a dog, this is a cat, and it learns like, hey, when I see a feature that looks like a floppy ear, that's probably a dog, or when I see like sharp ears, that's probably a cat, right? So like in older models, you actually used to be able to trick the dog-cat classifier by giving it like a dog that had sharp ears. They've gotten a lot smarter. There's a lot more going on here than just this, but like that's essentially how a deep learning, what we call a convolutional neural net works. This is basically how you classify images. So it takes pixels, it slowly builds those pixels up into shapes, and then it learns based on the data you gave it what kind of image that is. So what that actually looks like, what that first layer actually looks like, this is Gene Kogan. He uses classical machine learning for artists. It goes way more in depth than I do, but it's definitely worth checking out his resources. These are what the first layer of what we call filters looks for. So basically this passes over the image, and wherever it captures something that is sort of a similar shape to that, it like registers a beep, right? It's like if you pass this over with like, it's almost like a what is a metal detector, where it's like when it passes over a certain part of the image that matches up with the filter it sees here, it beeps, and then it keeps track of that, and it just begins to add them up. So like in the case of maybe the second row down, first column, like that's looking for hard vertical edges, right? If it matches that with say, I don't know, one of these other ones that's more horizontals, you basically have an edge of a box. So that's sort of how it works. So when you combine all these, like you basically build them up further and further and further until like it has a representation of maybe what a dog nose or a cat nose looks like. So this is how those things begin to build up. So this is like running on a photo of him. So like you'll see that some of these filters really only pick up like verticals. Like this one only picks up really vertical images. This one really picks up horizontals. And as these begin to build up, it actually generates like what the shape is supposed to be. So this is a way of detecting different facial features, different features of an image, like that sort of thing. So the other thing that's been pretty crazy in the machine learning world is that the very first generative image maker was theorized and produced in 2014. This is 32 by 32 pixels. And 5 years later, I think this is actually maybe 2018. So 4 or 5 years later, we are at 1024 by 1024, and we're up to 2048 by 2048 now, depending on the size of your machine. So in 4 years, we've gotten not only like drastically larger, high resolution, but we've also gotten way more realistic.
So those are generated.
Yeah, sorry. These are all fake faces generated by a model.
It's the last one. This is not a person.
The last one is from the model that produced This Is Not a Person. Yes. Yep. Yeah.
Is there a direct connection between the data you feed, in terms of resolution, the data you feed and the data you get?
Yes. So in the particular networks that we're going to use, you have to feed in, it has to be equal. So if you feed in 1024, you're going to get out 1024. So if you feed in 128, you can't get anything bigger than 128. Yep.
It gets creepier the longer you look at it.
It does get creepier the longer you look at it, and you can, there are ways now that I know how it's fake, which is like this hair. You can usually, if you usually start at the hair, you can tell a lot, because the hair is like where it gives it away.
Weird artifacts of
There's-
visualization or something.
There's weird artifacts. The other thing is, everyone always uses this as a model of how great we got at like generative imaging. But the funny thing is, faces are like the easiest problem to solve, because if you put all of our faces perfectly aligned over top of each other, there's very little differentiation in our features. But where there's a lot of differentiation is in hair. So that's why the hair looks the worst, because that's the part where it can't really understand most of our features, right? Like most of us, our eyes are maybe a little bit further away or a little bit closer together. Our nose shapes change a little bit, but like our general face structure doesn't change that much, right? Like no one's eyes are up here or like down here. So like this model is actually very, very easy to produce. Like I say very easy in that it's easier than other problems, but it's still very hard. But there's still areas in which you can tell like, oh, this actually still isn't working. There's actually a new version of this model, which is what we're going to work with, and it actually has gotten better at like learning hair, and it's like kind of getting really creepy about how realistic it actually is getting. Yeah. Okay, so that was sort of like it for machine learning. Now we're going to talk a little bit about machine learning art. So I love this quote. Alison Parrish is one of the people who teaches a lot of machine learning stuff. If you're into poetry, she is like the person to follow. She does machine learning poetry, and it's amazing. This is sort of her theory about why she thinks machine learning art is interesting. And it says, asking, can a computer generate Shakespeare, to me is less interesting than asking, what would Gertrude Stein have made with TensorFlow? And I think this gets to the point I think you made, which is like, I am not interested in machines just generating stuff on their own. I'm interested in what does an artist or what does someone with a specialized knowledge use machines to build their own practice around, right? So Gertrude Stein is a great example, because Gertrude Stein was like a very formalist type of writer. She experimented like with different types of writing, different ways of writing, and the idea is like with an artist or with a expert in words and language, using models, like you get a much more interesting result than you do just like giving a random person like, hey, try to write Shakespeare, or like, you know, it's sort of the, what is it, like 50,000 monkeys will randomly write Shakespeare or whatever, like that sort of theory. Like it's the same thing with machines. Like if you throw enough computation power and enough time at a machine, it's going to generate something beautiful. But if you use a machine and a person who already writes beautiful stuff, like you're going to get there much quicker and much faster. And that's exactly why I teach this class. So like most of you are artists or like have interest in art or like have some aesthetic value. Like you're going to produce more interesting art than like say a random scientist trying to generate images, right? Like you're going to pick an interesting category, and that itself will generate interesting work. I also think that like machine learning is a really interesting time to start working. Like we're like 4 or 5 years into this technology, and I think there's some really, really interesting opportunities. I liken this to like early modernists, like photographers. So this is like Moholy Nagy and I'm blanking on somebody else's name, Jurgi Kepish. So like I think there's like a really interesting parallel here to like early photography and early machine learning, and like part of being an artist using these tools is you're actually defining how they're used in the future, or you're finding different experimental points within them. So I think there's a lot of interesting opportunities to be a person working in this field right now. I always throw this in about why you might not enjoy this class. Too late, you're here, you already paid for it. But just in case, like, here are a lot of reasons why people don't like doing this work. It is expensive. We will talk about why it's expensive. Although I had a person in my last class who was like, I'm into pottery, and this isn't nearly as expensive as pottery. So, you know, okay, we're cheaper than pottery. That sounds good. It is time consuming. It's time consuming in an interesting way. It is very slow in that it produces stuff over days. But what I find really interesting about the time consuming is, again, it's like pottery, where it's like you're busy and active for 2 hours, and then you just let it run. And then you come back to it 2 days later, check on it. You might be busy and active again for a little period of time, and then you let it run again. So it's time consuming in that I think we're so used to a world where like you can generate an image in 5 minutes, 10 minutes, and you don't get that with this. So it's an interesting time consuming, but it's not like all consuming, right? Like I feel like if you're a serious painter who works with oil paints, like that's all consuming in how you work. Low resolution, we'll talk about this. Like we're getting better at this, but like this is not like print quality work. Like you're still like pretty small works. There are ways in which you can make it larger and not just drop it into Photoshop, but like other things. But it's not the best thing to work with at like super high resolutions. It is hands off, so if you are into painting, this is not going to be a fun class for you. Or maybe you just find a way to make it fun in a different way. If you've done anything with generative art, I think it's very similar in the sense that it's like you're not producing one image that is beautiful. You're producing a set of images with a range of quality, and your job is to pick out the best ones from that. So some people come in and they're like, I want to make an image that looks exactly like this. How do I do that with machine learning? And I say, you can't. Like, you can't. I think people have gotten more known for me as a machine learning artist, and people will reach out to me and be like, I want to do a thing where I like make my face in a model and like that's it. And I'm like, just take a photograph of yourself. Like it's not the same, and also it actually is really hard to do. So it's like, again, I think there's a place where people are misunderstanding what machine learning art does or doesn't do. And I think hopefully through this class you'll learn a little bit about that yourself. I'm often here, it's hard to know where to start. That's why you're here. And I often hear that I've never seen examples of stuff I like. I hope that you will have that solved in the next hour. So like this is like, just so you know, here's some things to know about the class. Before I jump into a bunch of examples, are there any questions?
Are all models open source?
No. All the models that we will use in this class are open source, but most of them are not. Like in the generative art world, it doesn't make any sense to own your own model. Like it's sort of worthless because there's so few people working on it. But in the case of like more classifier data or like classifier models, like places like Uber, Google, like they have a ton of their own privately sourced models. We're fortunate in that there's no business sense in owning your own generative model essentially at this point. So most of them are research labs who open source it and put it out. And we'll also talk a little bit about how to find good models versus bad models. Like basically my number one rule is that if someone open sourced a model but doesn't actually have examples on how to use it or how to run it or a tutorial on how to run it, it's not worth using because they don't care enough about it.
Do I need to know coding?
Yeah, so you don't need to know coding. That's a great question. So you don't need to know how to code for this class. What's cool about this compared to like generative art is you don't need to write any code. You do need to learn the steps and operations to do it. And those steps include doing things that I think we commonly think of as technological or like software engineer things, like using terminal, like running a command in a script. So if you're not like super proficient in computers or that sort of thing, you might struggle a little bit. But what I would say is like all you need to do is actually learn the steps and go through the steps a couple times, and it'll sort of become ingrained in you. And it's I will often say easy in this class, and I will often catch myself and try to stop saying that. But I think it's learnable in a very short period of time. And I will like, if you particularly struggle with if you particularly struggle in those areas, like let me know and I can help sort of like write up guides about how to do these things. It's mostly like, it's learning to write like a sentence, right? It's like, do this and then this and then this in this order with these particular like differences, and that's how you learn. But yeah, so there's no coding. It's just learning to do different operations, and it sometimes will feel a little different if you're not used to it. Any other questions? How are we doing on time? Perfect. Okay. We might go a little long, but hopefully not too long. Okay, so I'm just going to quickly run through some models that we're going to potentially learn in class, and I'll name some artists, I'll show some work, and I think the thing here is to like think about what you're really inspired by, or if it gives you ideas to work on things that you're interested in. So first is StyleGAN. This is like the most popular model right now, in part because it's really well produced and there's a lot of tutorials and other people into it, so it's got a little community around it. StyleGAN is the one that produces the faces. It's like the most famous face model. This is an example of sort of the faces they made. This is from the previous version. I'll show two different versions. And one of the things that's really interesting about all this stuff is that because it's basically numbers underneath it, you can do things like you can basically add and subtract images. So what you're seeing here is you're seeing an image on this left-hand side being added to the images across the top, and then in the middle here you're getting what the output is. We'll talk a little bit about how this works, but like basically this is a thing you can do. You can add and subtract faces because it's all math under the inside or underneath it. What I find really interesting about this is where we break it. So you'll find that I'm not necessarily interested in realism. I'm interested in where we do weird stuff with pseudo-realistic things. This is Keisha Yuma. So what I think is going on here is he fed a video of basically break a video into a bunch of frames, do this with it in the video, feed it back to this model, and it learns like kind of what different hand structures look like, but also not. Like that clearly isn't a real hand, but I think it's really interesting how something so simple as like a video of just some hands run through a model like this produces something really interesting, somewhat alien, but like still recognizable. I think that for me as an artist is the sweet spot. It's that sweet spot of like realism with a little bit of alien, like what the fuck is going on here. I just generally like that's sort of my shit right there. So one of the things you can also do with StyleGAN is you can project other images into it, and you can force them to do things that are weird. So there is basically like if you imagine images like this, you can again imagine an image where like frowny faces are all on this side, smiley faces are all on this side, and if I want to animate a face between those, I just run along this line. And so that's essentially what we're doing here. Is we found within this particular model what the difference between smiling and frowning is. Then we push an image into this model, and I'll talk a little bit about projection and like when we actually do StyleGAN. Is this like a little bit harder concept to follow? Basically, you push this image into it. You then have this image, and then you can animate different dimensions of it. So I think I've seen that there's like a hair color dimension, or like a hair length dimension. So we can make Mona Lisa be bald or something. You can then make her smile, like different things. So you could technically do this with any StyleGAN model. The work behind it is pretty complicated, so most people have just done it with faces. Most people also just work with the face data set because as humans, we're all obsessed with our own faces. So these are two pieces of my work. So StyleGAN 2 came out about 4 or 5 months ago, and it's a dramatic improvement over the first StyleGAN. So you'll see like this is essentially the same model trained, and you can see like here like just the textures, the understanding of shapes is like so much better. But I'd also say like I've had a lot of people tell me like I just prefer this one. I like it because it's weirder. So like again like don't feel like you have to use the latest and greatest if you like the look of something older. Yeah. So.
Can I ask you? I know we're gonna probably get into this later, but like for when you made that, how did you? What is your like your data set?
So my data set for this was 1,000 images of old vintage flower, like painting drawings or whatever. Mm-hmm. I hand cropped all of them into like basically imagine like a big like shrubbery scene. Mm-hmm. I like hand cropped each of those like smaller pieces, and that's why I got this effect with it, which is different than like. So the other thing we'll talk about with data sets is like I could go grab a bunch of images from the internet and I would have a data set, and that's totally fine. That's a totally valid approach. But like, if you take a next step of doing some manual labor, you'll get a much more interesting data set, and it's also yours. Like, no one else is gonna follow you into that work. So yeah.
Do you mean like cleaning it up? What do you mean crop?
Yeah, so literally cropping into it. Let me see if I don't know if
knocking out the background or like.
No, it's literally, so it's like it's just a plant. It's a plant illustration, like a scientific plant illustration. So it had edges and other things, and I just cropped out a square of it.
Oh, gotcha.
Yeah,
oh,
yeah.
okay.
Yeah.
Gotcha.
So yeah, so it's just like, it's a crop of it, but because it's a crop of it, it took me like a whole weekend to actually produce those images. No one else is gonna follow me to like do that work. So it's like a little bit of like, how do you separate yourself from other AI artists? And that's one good way to do it.
So when you started this project, like what was your intention initially before like the V1? Like what was in your head, or what was kind of your prompt to start?
I just knew I wanted to make some fake flowers, and I knew I wanted to generate like different shapes and different textures. I think the thing is with this is it's always like, I'm gonna generate something fake, and it's like, well, what does fake mean to you? Does it mean still realistic, but like different colors?
Mm-hmm.
Does it mean non-realistic? Like, you can tell, like, if you look closely, like, you know, if I were to just flash this image in front of you, be like, yeah, that's a flower, whatever.
Yeah.
But if you look here, like, you can see, like, normal flowers don't operate like this. Like, this is a leaf, and there's a flower bud at the end of the leaf. Like, that doesn't work. So, like, and also, like, these shapes, like, you wouldn't ever have a flower that is those shapes together. So yeah, it kind of depends, like, what do you mean by fake, or what are you trying to actually produce? I had previously trained a model like this on the whole image, on like the whole like flower shape itself.
Yeah.
And I generally wanted something that was like better resolution essentially, so I started cropping in on it. And that's when I got like this better detail on it.
In terms of like what takes time, so preparing the data set takes time, and then training the model takes time. But generating also takes time, like rendering or like exporting?
Rendering is actually pretty fast.
So
Rendering a
what's
video
trained?
like this, I can do a video like this in, if it's a minute long video, I can probably do it in about 10 minutes.
So training takes the most time? Like prepping the data set and
Prepping your data set, depending on what your data set is, can take the most time.
Okay.
And then training takes a lot of time. So a model like this trains for about 3 or 4 days. That's just generally what works, that I find is like the right amount of time.
That's just running out there in the ether.
It's just running on a machine for, you know, whatever, 120 hours or whatever that ends up being mathematically. Yeah. Yep.
And there's any way that you can know what's gonna happen instead of spending hours on preparing this data set and you
No.
know, maybe
History.
doing half the way?
Yeah, I mean, it's tough. That's the hardest part, is you don't really know what you're gonna get. Also, when we talk about StyleGAN in week 3, I'll talk about like, there are places where things just fall apart and they fail, and you don't always know why. So that is definitely an outcome that can happen, and is a big bummer, where you spend all this time making a model, then you trained it for 3 days, and at the end of day 3 it like fucks up and you're like, what happened here? It definitely happens. Mathematically it's understandable why it happens, but like it still sucks, and you're like, you could retrain it and it might be fine. There's a little bit of just failure rate. There's a lot of randomness in this stuff, so there can just be a failure rate of a certain amount with these things. So it does happen. We can talk about why or how, or like what do I do to fix it. But yeah, in general, you don't know what you're gonna get until you, like, you can see it train. Like, you can, like, while it's training, you can come in and look at a bunch of fake images and check them out, and it might give you a sense, but it's always just a little different. Like, it's always just like, early versions, you might just be like, I don't know if I'm gonna love this, and then it gets a little bit further along, you're like, oh, I really like this, and then it like disappears again. So again, it's just like a little bit of, it's like, that's kind of how making art works too. Like, I feel like sometimes it's like, if you're painting something and you like add another stroke, you're like, fuck, I screwed it up, you know, that sort of thing. So it's all the same thing. I want to show, this is actually a piece from a student that I had last class. So she did this, and I think in the last week of class, like, this is what she produced. She's an avid birder. She like knows all the different genuses and species of birds, and she scraped like a huge data set. I think like something like 20,000 images of a particular bird, like a particular, like, the male species of a certain bird, and she produced this little video. And I think what I love about this video in particular is like, and it's what I talked about with her, is like, it covers like this very the very obvious genre of bird photography, which is like the bird is always centered and there's always a single branch that they're sitting on, and like you can basically see that like for part of it, oh shit, that's the wrong video. Like the bird doesn't move, but everything else moves around the bird, and that is so like unique. Like you would never see that anywhere else. So I just think it's a really interesting model, and I think it's also a great case of where someone who knew what they were looking for was able to make something that like I couldn't make this. I just grab a bunch of random birds that I thought were orange, and it just wouldn't produce the same sort of result. So this is a thing called projection. We'll talk a little more about this in StyleGAN when we talk about StyleGAN, but it turns out these models learn way more than you think they do, and then you can start to find weird shit in the models. So this is literally someone who found the Mario inside of StyleGAN, inside of what's called SSHH3, which is the main face model that everyone uses. But really disturbingly weird stuff. I find most of the machine learning art is just disturbingly weird in its own way. So like it's just a class of like horror artwork, I think. I can't believe it's still going. Wow, you even found a mustache. I feel like I've never actually watched this all the way through. Yeah, wow, you even found the mustache. That's so fucked up.
The jiggling really.
Yeah. So the jiggling is basically, it's trying to guess which direction to move in the model. So again, if you imagine a space like this, it starts here and it tries to find its way like to the closest image that it can find. So like it's wiggling because it's trying to find the best representation.
This is, I mean, I think most of the similar art I've seen is kind of like, doesn't have like beginning and end, and this has like a clear end goal. What's
Yeah.
like, how does that work in terms of like?
It just depends on the type of script you're running into it. So again, this is like, it's trying to find the closest representation. And all you're seeing animate is like, it starts here, which is like, it actually starts in the middle. It starts at the most average point it can. And then it like very quickly jumps to where like it knows it needs to be. And then it like just sort of wiggles around. And like basically at some point we just tell it to stop. If we let it run forever, it would just keep trying to get closer and closer to the place it needs to be. And it just would like, it wouldn't change a lot. So yeah. Okay, so another model we're gonna look at is what's called Pix-to-Pix. Pix-to-Pix is this. So StyleGAN takes one folder of a bunch of images that are all kind of similar in their own way. Pix-to-Pix takes two folders of images, but they're still really what I call tightly correlated to each other. So at the top here, we have what's called segmentations. Segmentations are super common in machine learning, mostly because it's like vision recognition. You also find a lot of these models are built for like autonomous vehicles. So anyway, so like at the top here we have a driving scene, and then the segments of like anything in blue is a car, anything in purple is the road, anything in green is a tree, to its segments. So basically what we do is some poor intern goes in and like takes an image and like maps it to a segment, like either by hand or like maybe there's some tools that help them do that. They do this for like 30,000 images. Then you can do the reverse. You can then generate a fake segment and it will generate a fake real scene for you, or you give it a real scene and now it can make a fake segment out of that. Something like segmentation is like a huge thing in machine learning. There are a bunch of models on Runway that can allow you to do that. I actually want to make sure I turned off my Runway model. I did. Okay, cool. Make sure I wasn't being charged tens of dollars behind the scenes. So this is basically Pix-to-Pix, and you'll see there's a bunch of different versions here where they generate like two of the exact same image in different styles, right? So actually the way we do black to white, or actually the way we can generate black and white to color is actually doing the reverse. So the way you train the data is you take a bunch of color images, you turn them into black and whites in Photoshop, and now you have your pairs. And then you can take a black and white image that's never been in color and generate a color image from that black and white image. So there's an app called Deoldify. You can look it up, you can buy it, and it basically converts old pictures from like the 1910s or 20s to color. And that's because it's been trained basically doing the reverse. So how you make these data sets is like, these are actually the most laborious data sets to make because you have to make something that's really tightly coupled. This is also how our cameras work in our phones. So if you've ever taken a really weird discolored image and then it magically is like corrected, this is basically the process that phone cameras go through. So our like iPhones are like 90% machine learning at this point. Like the photos you take, like what is it, portrait mode? Portrait mode is a machine learning model. It's actually not, it doesn't have anything to do with the camera or the lens or anything like that. It's just machine learning. So there was a thing maybe a couple years ago called Edges to Cats, and you could go in and you could make a really cute kitty by just drawing its outlines, and you'd hit process and it would generate a kitty for you. And within days, people made the most fucked up looking things possible. This again is like, so again, how does this work? So in computer vision, there's a way to generate edges. So basically, you took a bunch of cat photos, they generate edges from it, and then they trained it on edges in the cats. And then the idea is that like some human could generate a realistic edge of a cat, but like most people just end up doing stuff like this. So like maybe this is how you want to make art. I don't know. Like there are ways in which you could generate art from this, and I think there are people who have used a similar model to this that makes really interesting stuff. This is Scott Eaton's work. Scott Eaton happens to be so I talked about being an expert. Scott Eaton happens to be an expert at 4 different things. So he's a 3D modeler. He also has access to a really amazing photo studio, and he's a wonderful figure drawing artist. So he combined all of those into a machine learning model where he can now draw super fucked up figures doing different things. There's a great video that's linked to in his deck if you ever want to watch his process and how he actually learned to do this stuff. Just really mind blowing how he basically made the perfect data set for himself based on what he knew and based on what he learned. And that's the holy grail, right? Is we could we wouldn't have to scrape the internet for photos of cats. We could just buy 500 cats and photograph them perfectly or whatever. So this is part of what I think is really interesting work, and also a place where an artist who has all of his expertise, no one is going to touch him on this stuff. Only he could do this work. This is what's called Gauguin. This is where I was talking about the segmentation map. So basically this is a way for you to draw segments, and you draw these little segments and it starts to generate scenes. One of the big players in machine learning generative art is NVIDIA. The reason NVIDIA is really into it is because they make graphics cards, and they know the technology, and then also they work with gaming studios. And if you know any gaming studios, the number one thing they will tell you is their bottleneck is artists. Artists are their biggest bottleneck. So this eliminates some artists, or I don't know, maybe it productionalizes their work and makes their job nicer. I don't know. But basically, this is a really interesting way to generate images and scenes. And there are a bunch of people in the demo scene world who are using this now to generate different images. Okay, CycleGAN and Munit. CycleGAN is the sort of original version of what's called a CycleGAN network. Munit is a new version on top of that that's made by NVIDIA. They're generally the same thing. There's a couple different tweaks between each of them. So what's cool about CycleGAN is that in that text-to-pix version I showed you, they have to be the exact same image, right? So it's really hard, it's easy for me to say oh, I want I guess look at the examples here, right? How often would I be in the exact same location in Yosemite during the summer and winter? Literally the exact same location. You could do that with if you set up a camera and you just have it run 24/7, you could maybe get an image like that. But CycleGAN actually says, I don't care about that. I just want a bunch of images. So give me a bunch of winter images and give me a bunch of summer images, and I can learn the difference. And that's pretty crazy when you actually think about that. So that's where horse to zebra comes in. Think about it. You can't actually get the exact same pose of a horse and a zebra. It's just not possible. So this model takes just a folder of horses and a folder of zebras. They don't match up at all, and it learns how they connect, which is pretty crazy. But it's pretty interesting how it works. This is my favorite version, which is Faces to Ramen. So this generates ramen or faces from ramen. But again, I just love when people do weird stuff with these models. And you can kind of see actually how it's translating, right? Look at, what is this guy's name? I always forget his name.
Owen Wilson.
Owen Wilson?
See how the egg is his forehead, but then you can still see his hair there. It's pretty interesting how it actually translates these things. But yeah, so we'll talk more about CycleGAN and how it actually works at a later date, but I think it's pretty interesting. If you're into collage, Helena Saren's the person to look at. Helena does really amazing CycleGAN work where she just combines multiple stuff over and over and over again. And I think someone asked me how many images did we use for horses to zebras? So horses to zebras is 1,000 images each. Helena's work works in images of batches of 10s and 20s. So there's a there's a downside to that, which we'll talk about at a later date, which is called overfitting. But again, if you just want good images out of it, doesn't matter. Like overfit actually doesn't really matter in that case. But she just works sort of like repetitively throwing her old work, recycling her old work back into a new model and like generating stuff out of it. Just really interesting work. She's super prolific, produces a lot of work, and there's some really beautiful stuff that she's producing. This is some of my own work. This is floral images and bird images. What I think is really interesting here is the top, like there was nothing around the outside of that bird in the original image, and it just generated like some floral stuff around it. And then on the flip side, so what's also nice about CycleGAN is you get what we call A to B and then B to A. You get both translations free from the same model. So the top one is generating birds to flowers, and this one is generating flowers to birds. And like you can see in this texture, it's like really close to a bird feather, right? It's like, this is really interesting. It's like the structure of a like plant, but it has the feathers of a bird. Super weird, super interesting stuff. This one is like the flower buds became birds. It's like super weird, and if you look close, it like looks really deranged and weird. But it's a really interesting model, and it does a lot of cool things.
So for these, the input for each one of these is a single image?
No, it's actually a collection of images, probably about 500 images each. So
no,
it's
but like to generate one image that's like moving, like taking a bird and making it a flower.
Yep.
Is
Yes.
it one specific
It's
image?
one image.
Okay.
Yeah. So it's one image. So you train it on the folders, but then you feed it one image. Yep, that's right. Yeah. Yeah. And this is some recent work of mine, which is again, it takes faces, and it also uses flowers, and it generates a fun little like flower face thing. If you saw the promo poster for this class, this is how this was produced. We actually I might do something fun next week where we actually like all take photos of ourselves and produce it through this model. So that could be kind of fun to see. What is cool is like, again, generating images with this is really quick. It takes like 5 seconds for each image. So I've seen people take something like this and turn it into an interactive display where you could like have a selfie booth and it'll convert your images. The training takes a while. The training takes a couple days. But once you have the model, then spitting an image or passing an image through it is very quick. So this is trained on a thing called Munit. The nice thing about Munit is, so here, if I give this same model the same bird image, it's always going to spit out the exact same image. That's CycleGAN. So it's learned like a direct translation. It's learned like how to go from A to B. So no matter how many times I give it the same image, it's going to generate the exact same like output. CycleGAN or Munit has a different output where it actually can generate thousands of different outputs. They're all pretty similar. Like I think most people will say like they're generally color, but if you look at this, it's not just color. There is some texture differences too. Like you can see in some of the details, the textures are different. So it does learn a little bit more, but it's still generally like pretty close to each other. But what I like about this is if you're like an artist or a designer and you want something specific, you have a bunch of options available to you. Whereas with CycleGAN, you get one option and that's it. And you might like it, you might not. So Munit tends to be what I teach now, and it's interesting because you get multiple different options out of it. I'm just going to play a little bit of this. This is a video by an artist called Memo Acton, and this is just one of my favorite pieces. I'm just going to shut up and we can watch it. All right, so there's a couple different modes of this, and I'll let everyone else watch them. But what I love about this is when he drops in like the chords. I'm just like, oh shit! Like it just like, it's really amazing to see what you can do with something so simple, right? And like if you were to hide everything on the left hand side and you were to just watch this, you wouldn't know at all how he's making it. And I think it's just really interesting, like super creative use of like something like a cyclogan network, right? Because again, there's no way for you to accurately map exactly like this rock image to this like alignment of your phone cable. But using cyclogan, you can get pretty close approximations. Okay, next stream prediction. So next stream prediction is actually a pix-to-pix model. It's just a very specific use case of pix-to-pix. We'll watch this video by Mario Klingemann, who's probably one of the best known like AI artists. I'm actually going to start this from the beginning. So pix-to-pix works by, again, remember that pix-to-pix is a model, takes an A input and a B input, and they have to be really tightly correlated. So what this does is it takes all the video frames of a video, and it matches frame 1 to frame 2, then frame 2 to frame 3, frame 3 to frame 4, and it basically learns motion. So this has been trained on fireworks, and you'll see that it's not that great of a, like it understands fireworks in some like abstract way, but it doesn't really represent like realistic fireworks. So next stream prediction is a really interesting model that tries to predict motion, but ends up like destroying half the images that it makes. This is Jonathan Fly's work, who's another great person to follow on Twitter, because he just explores every single model under the sun. So you'll see it kind of like picks up some of the motion of it, but it doesn't do a really great job of it. So this is why a lot of people like next stream prediction. It's like glitch video, like on crack. It's like really interesting, but it does like a really poor job. Again, if its job is to like guess motion and actually be able to like fake animations, it sucks. But it's still a really interesting model in that it picks up some of the general motion of things. This is some of my own work, which was trained on like early 1920s like film animations. Whoops. Oh, Leah's name is in there because I was supposed to put her work in here instead. So again, it like looks nothing like the original video, but it's still pretty interesting. This is another piece of mine. So in these cases, like you can see what the original video is for the first couple seconds. And you'll see what it like devolves into at the end.
Did you do that on purpose, or is it like real-time computing?
So the way it works is you feed it a real image, and then it produces a fake image from that, and then you just keep feeding it the fakes it just produced, and it just kind of goes crazy after a while. Yeah, it just like it gets further and further away from ground truth and just starts going crazy. So like I can't predict when it's going to start doing that weird flashing thing. It just kind of does it based on things it's learned.
Is there a limit to how much it can continually produce?
No, I could probably produce a 2-hour video of this. Sometimes what'll happen is we'll hit a black frame. It'll be like, cool, there's nothing after a black frame.
Yeah.
So sometimes it does stop, but I could probably produce a video of this for hours on end. Okay, style transfer. People probably know style transfer is this, which is like the most gimmicky shit on earth. But this is like, so style transfer came out probably 2015, 2016. And like a bunch of people have made essentially what I would consider like the fart apps of style transfer, which is like doing this with selfies or doing other things. It's a fine technique, but like using it with the same 5 cliche images just sucks. And it basically like killed style transfer as like an artistic medium because this is all people think about it. But it's a really, really interesting medium. It's fairly easy to do and it's fairly quick. You can produce a high-res photo in about 5 to 10 minutes now. This is Mike Tyka's work. Mike Tyka is known mostly for doing Deep Dream, if you've ever seen that. But he also experimented a lot with different types of style transfer. This is actually one of the very first projects I ever did in machine learning. This was like from maybe 4 or 5 years ago, which is like applying textures to typography. Apparently that image disappeared. Oh, it's loading. Okay. So again, I tend to work a lot with flowers and early historical images and applying textures to those. So again, if you take style transfers that aren't just from like cliche pieces of art, you can actually generate some really interesting stuff. This is actually from one of the students from my last class who took anime illustrations and applied them to Air Force Ones. And what I really like about this process too is she shared her process, which is like, okay, it's a white Air Force One, here's an anime photo. What it actually generated was kind of this like kind of messy image, but then she took it into Photoshop and just applied a mask to it, and you still got a really clean image out of it. So I think like again, this is a case of where like the actual style transfer wasn't maybe the best thing, or like if you just said like this is the image, like it wouldn't be good. But like she took it one step further and actually made it into something that I think is really interesting and really like textural, and like I would love to see someone actually produce one of these. You can do video with style transfer. It's actually a really laborious process. It basically converts every single frame of a video into a style transfer. So it takes 10 minutes per frame, and you do that for 1,000 frames. It's going to take 10,000 minutes. But it's a cool process. It's like really interesting. This is a person, XU Lulu, on YouTube. They produce a ton of videos, and it's really cool stuff. There is a little bit of a special trick you have to do with this to make sure that it doesn't get flickery. So basically, if you do it without, there's the other thing that's called gradient flow, which just tracks motion and like masks out certain things. I have a demo video of this if you're interested in it. It is a laborious processor. It's slow. It takes a lot of time to produce it, but it's really cool. This is one of the videos that I've done, which is basically like applying motion to a static image using style transfer. So the image under here is actually like completely static, but you're generating interesting like sort of textures over top of it. Okay, so those are sort of the models that we'll be looking at over this class. But the last thing I want to talk about is I think things we've all talked about in here, which is like AI is actually a tool. It shouldn't be the end result of what you make. And here are some artists who I think are doing really interesting stuff of having machine learning or AI as a part of their process, but not just stopping there. So this was the video that I actually produced for this class. It's actually multiple pieces of different networks. So there's actually StyleGAN in this to generate the motion, to generate the video of the different faces moving, and then it uses Munit to actually generate the textures on top of that video. So there's actually a couple pieces at a time. Braulio posted this, and I think we asked people to guess who the celebrities were in this video, and I think everyone got, I think the one person got 3 of the 4, but the one they missed was this person. So I think it's really interesting that like basically we use StyleGAN to push a celebrity's photo into the model, then animate between all those images, and then using that, then bringing that in to texturize stuff with the different with Munit. This is Mario Klingemann's work again. So this is probably multiple. He's actually never said how he did this, but I think it's multiple. People have inferred that it's multiple networks of CycleGAN. So it's basically faces that look for. Have you ever seen the motion tracker of a face, like a basically where it tracks your shape of you? So it's basically like he'll do one frame of that. He'll then put in a face tracker to generate the face tracking. Then he takes the face tracking and he generates a new image from it. So that's why you see the faces split off, where it's like it doesn't actually know where the end of a face is, and it just starts to split off faces. But really interesting in a way to take like sort of a complicated tool chain to generate some really interesting work. This is Sophia Crespo, who did these GANs and then like printed them on cyanotypes. What I like about this is like it actually is sort of like more of a storytelling thing, right? It's like she made these very like weird sort of like, I don't know, primordial like animals and flowers or whatever, and then you make a really like old looking image of it, and it's almost like, did this person like find this thing in like, you know, I don't know, it's like a weird horror thing of like, did they find this thing in their backyard and they were like cursed for the rest of their lives or whatever it is. So I think like this is a really interesting way of like, you know, again, it's like I'm sure the GAN of this was like very colorful and probably very bright, and like by taking it and reducing it down to this like vintage sort of look, it like generates a different story for the thing. David Young, so David produced the image on the left using a GAN. he then sent it to a painter and had it painted. There's like services where you can like ship stuff to like Malaysia and someone will paint an image for you, which is fucked up in its own way. But like, it's kind of interesting that like this painter chose not to like represent this image exactly, right? They kind of changed it a little bit and made it their own. Robbie Barrett's work has been really, really interesting. Robbie is like, I think he's like 21 now, but when he started, he was like 16. And he has been producing like all sorts of different GAN images. So him and this guy Mushba, I think it's a guy. I hope I didn't misgender them. But they took a bunch of runway images and they generated a GAN from this. And then they said like it's really weird that it made this like bag on this guy's leg. Hey, let's make one of those. So they actually produced some clothing based on this. And what they ended up finding out was that the machine learning model learned about handbags. So actually someone was carrying this thing. But like it also realized that sometimes there aren't handles when they're carrying stuff. So like it generated a model where it was like it kept the bag, it lost the handle, but it generated this really interesting output. So they had someone make this like leg bag. And he sort of kept going on with this idea. So this is some work that they produced sort of independently. And then about 5 weeks ago, Acme came out with their new spring line, and it's all inspired by Robbie's work. So he actually produced and worked stuff with Acme to generate these like glitch textures and patterns. So like here's an example of someone who's like really taken it and like is now working with a pretty famous fashion house to make this stuff. So really cool work. And Robbie is also one of those guys. I don't know if you heard about the story where like a random company like put up their AI image on like Christie's auction house and it like went for like $450,000 and it turned out they used someone else's model. They used Robbie's model. So Robbie's like very famous in the AI world of kind of having been ripped off, but like there's a lot more nuance to it than just that. But really interesting stuff. Okay, how much time do we have left? 15 minutes, perfect. Okay. So hopefully that inspires everyone. Like I'll share this deck after class so you can go back and look through the projects. But hopefully like your mind is starting to generate some ideas about things. So for this week, that's pretty much it. Like the idea is like hopefully you come up with some ideas this week. I'm gonna talk a little bit about what tools we're gonna use throughout class. So we're gonna use a thing called Paperspace. That's the thing I would like everyone to make sure they have their account set up for. So also, I have everyone's email addresses. If the email you signed up with in Paperspace doesn't match the email address I emailed you with, please let me know because I need the actual email address you signed up with so I can white label your server account. So Paperspace is a server. We need a specialized server because you need a really good graphics card to make these things. So like a gaming graphics card or better. They mostly have to be NVIDIA. They mostly have to be running on Linux, which is like almost none of us run stuff on Linux. So like it's easier to rent someone else's server that does all that for you. It's easier for a lot of reasons. It tends to be faster. It tends to be much easier to use because you don't like basically if you were to try to do this on your own laptop and you had a good laptop, it would lock up your laptop while it's running. So this is a nice way to like you use someone else's server, you pay them money, but like you have a server you can use and it works really effortlessly. So we're gonna use Paperspace. I'll do a bigger demo into that next week because I know some people said that they don't have a lot of experience with that. So I'll show you how to use Paperspace and how to use some other terminal commands and stuff next week. Runway is something I demoed this week. I showed you a little bit in Intention GAN how to use that. Runway is a cool tool because it has a bunch of models already in it. So you can sort of go in and you can sort of explore with them and play with them and see how each model works or doesn't work. It's a really nice way to sort of explore things. Runway costs 5 cents a minute. So it is not cheap. That is pretty expensive. That is way more expensive than Paperspace. But it's easy enough to use, and you only need to use it for an hour or two at a time, so it's like fairly inexpensive. And you'll have about $20 in credits to start with to play with for free. So it's like, for this class, that should be enough. We're gonna use Terminal and Python. So if you never use Terminal or like that, what people show is like the hacker thing that people use. We'll do a little bit of that. It'll be pretty, I won't say it will be painless. If you've never used Terminal before, it will be a little bit painful. But I'll try to like guide you through the easiest way possible. And everything will be like, I already have demos for pretty much everything. So if you're someone that struggles with that work, like you can just sort of like look at how I do it, pause the video, try it yourself. rewind, watch it again. Like it'll basically come through like a little bit of practice, and you'll start to get more comfortable with it. The woman who had the bird style GAN, like she told me, she's like, I barely knew terminal when I started, and I like now can like do a bunch of stuff in it. So that's one of the free benefits of this class. Maybe it'll be helpful, maybe it won't. We'll use that. The next thing we're gonna use is a thing called Colab. Colab is a thing that Google has. What's nice about it is it's free. It runs on a thing called Python notebooks, which you don't really need to know much about, but what's nice about them is it allows you to read text and then run code live in a web page. So you'll read some stuff, you'll run a couple commands, and then you can read more, and then you can run more commands. Because Google, it's free. It comes with all the Google stuff of they might be like checking everything you're doing and like copying it all for their own uses, but trust me, Google doesn't care about making art. They care about like taking over the world at this point. So yeah, but Colab's free, which is really nice. So we're gonna do some stuff where we're gonna train things in Paperspace, where it costs 80 cents a minute or 80 cents an hour, and like then we're gonna take the file from that server and bring it into Colab to generate images for free. So that's generally like how I work. Is you have to like basically you can't use Colab to train stuff because they have a time limit. They have an 8 to 12 hour time limit, which means you can't really run StyleGAN on it. So we're gonna do some stuff where we train stuff in Paperspace where like there's an unlimited time amount, and then we're gonna bring it to Colab to generate the images. This will also help you because a lot more people are putting their models into Colab, so you can actually play with it. So like learning a little bit of Colab will help you go a long way. Some other tools you might want for this class, but like aren't required, is an FTP client. I don't know. I feel like sometimes there's like 18-year-olds in this class and are like, what's an FTP client? And I always feel like an asshole, like an old asshole. If you never use an FTP client, it basically like lets you look at a server and pull all the files down. It's helpful. It's not required. There are other ways to go about it, but it is really helpful. There are some free options where they like bug you every 30 days to like pay them, but like you can still use it for free. Photoshop is helpful because you might want to clean up images. You might want to play with some other things. If you're an open source person, you can GIMP or whatever you want to use. And then lastly, like camera, scanner, etc. Like tools to make images are all really helpful. I think a really cool technique would be to like take a book and start scanning all the images out of it, especially if they're not online, because guess what? No one else is going to do that. So we'll talk about different techniques for building data sets next week, but these are good tools to have. Okay, so as a part of this class, you will get $100 in Paperspace credits. So again, that's 78 cents an hour, so it computes to about 5 days or so, a little bit less. We'll talk about how to actually run Paperspace, how to turn your machine on and off, save yourself some time, that sort of thing. We'll probably do that more next week. I have a demo video that I'll actually post in Slack probably this week, just to get you started if you're interested in jumping ahead a little bit. You'll also get about $20 in runway credits. Again, that like converts to what, like 6.5 hours, which is plenty of time. So that's what this converts to. You can run basically one StyleGAN model in about 4 days, so you'll have a little bit of extra. So like one thing to know is that if you want to do both StyleGAN and next term prediction, or you want to do multiple StyleGAN models, you will start to pay on Paperspace. You do have to give them a credit card, but you can keep an eye on how much money you're spending. And if you hit a point where you're like going to go over and you don't want to go over, you can just shut off your machine, delete your account, and like they won't charge you anything. So this class is set up so you can do everything you want to do, like in the amount of money you've given me or given us. But like, just know that like you will eventually hit overages if you don't delete your account or delete your servers, which I'll show you how to do. Okay, so Paperspace setup. This is I will again, I'll post the video for setup, and then next week I'll actually run through the steps. But in general, like if you follow the video, you'll be good to go. There's some steps in here where you have to give me access to your machine. You don't have to give me access, but it's helpful in case you run into issues later. Like something won't turn on or won't turn off, like I can go and look at it. There's a thing called ML in a box. Again, this demo video will help you like understand all this. But like basically you'll set up the server using ML in a box, using the P5000. This will cost 78 cents an hour, but it will be able to do everything you need it to do. So this is like basically what I recommend. You can go to a bigger machine, which I think is $1 an hour, and it won't really get you much more except it'll give you more space. And you will be able, like, you could maybe run multiple models at a time in there, but that's pretty tricky. So I just generally stay with this. If you don't know what you're doing, stay with this. That would be my recommendation. Collab, like I said, is free. We'll look at this probably not next week, but maybe the week after. Collab's fun. It's free. That's the nicest part about it. But it does have a max time limit, so it can be a little annoying.
I have a question.
Yeah.
By Python notebooks, do you mean Jupyter notebooks? Is that a little different?
They're the same thing.
Okay,
Yeah.
cool.
Some people call them Python notebooks. Some people call them Jupyter notebooks.
Got
They're
it.
the same thing. Yep.
Thanks.
And then Runway, we're gonna look at. So basically, like what your homework will be is to like play around in Runway for a couple hours. So there will be new models in there. It is 5 cents a minute, so it does cost you some money. I highly recommend that when you're done with Runway, you quit it. Every once in a while, there's a weird bug in there where they keep your model open, and if you don't quit the app, you're gonna come back like the next morning and find you have zero money left. So make sure you quit the application. They now have started offering training. So they do training like on a StyleGAN model in there. The problem is that they only do StyleGAN version 1, so they don't do StyleGAN version 2. When they do, I'll probably just switch this class over to using Runway. It's like a little bit faster. It's about the same amount of money, whatever. But I think people are generally interested in working with StyleGAN version 2, so I still teach that on Paperspace. You can run, if you like the look of V1, or if you like don't want to deal with terminal or other things, they do offer training within Runway where you just upload a data set and it'll train it for you. But it's pretty expensive. It's going to cost you about $50 to $75 to train a model, which actually is about the same of the cost that like we're going to do for this class. But I only have $20 in credits for you guys for Runway, and I had to use the money on Paperspace for you. So just know that it will cost you money if you want to use Runway to train stuff. But they do have some models you can train in there. Like you can train on StyleGAN if it's just version 1. Okay, so your homework for this week is I'd like you to explore Runway. So there's a couple ways you can do this, like, and I'll actually walk through Runway in just a couple minutes to sort of show you how to find your way through it. Basically, like, there's a ton of models inside Runway. Many of them are not the models that I've talked about in class. Some of them are classifiers. Some of them are other generative models that maybe just don't fit into the methods that I've been teaching or whatever. But I'd like you to just play around and explore and see what you can find. Like, there's just other stuff in there. What I think would be cool or like helpful, or what I found works in the past, is like find a model you like, just jot down a couple notes about it, maybe answer these questions of like, how did you figure out what the inputs are? What's the output? Like, what did you find confusing about it? Like, how did you learn about this? Did you Google it? Like, what else do you know about it? And just post it in Slack. So like, usually what people in the previous class did is they just posted like, hey, here's my homework for the week. Like, I looked at this model. I made a bunch of weird images. Here they are. I learned this about it. Or like, I didn't really learn anything, but it made some weird images, so I liked it. That's generally what people will do, and I think that's totally valid of that being your homework. So after this, like, if you want to stick around for 5 or 10 minutes, I can walk through Runway and just sort of show people how it works. There's a demo video online that I'll also post that just does the exact same thing. So that's basically your homework. The second thing to think about is start thinking about what you might want to make. So maybe go through, look at some of the artists I mentioned and look at some of their other work. And if you see something you're like, how do they make this? Generally pretty easy for me to figure out how they made it. But just start to think about like, also like, what are the, so again, if we think about, I guess Scott Eaton's work, like where he's an expert, or I think about Elena's work, who is a really big into birds. Like, what is your unique expertise, or like, what are things you're really interested in? So I think you mentioned you were really interested in collage. Like, what would collage look like in a StyleGAN model, or how would collage work in maybe, say, like a CycleGAN model or something? It could be really interesting to think about how they could explore those. So like, what are your interests, and what are things you know more about that other people don't? Or just like, I mean, it doesn't necessarily need to be that, but just like, what are things you find really interesting, and can we start to build a data set from that? That's probably what, like, and that's the hardest mental leap, is like, cool, I know I really like this particular artist, but there's only 50 images of their work. So like, that won't work, right? How can I find 1,000 images, or how can I find 500 images? So that's like, that's the mental hurdle, is like, how do I actually find all the data I need? And that'll be the challenge, for sure. So start to think about that. You don't need to think about how you can actually, like, you don't need to start downloading images or anything, but like, just start to think about how you might approach it.
Can you remind us what goes into a good data set, or like the core elements? So like a variety, or
yeah.
a lot of images.
So, I mean, definitely scale, like the number of images you can find is really important. and we'll talk about this more next week. So next week's really all about data sets, and I'll go into more detail about this. But essentially, it's like, can you find up to 1,000 images? So basically, StyleGAN's like floor is really 1,000 images. So if you can find 1,000 images, you're good to go there. But then it's like, are they high quality images? Like, so one of the things I teach is like, I'll teach you how to scrape Flickr, and Flickr has a ton of images on it, but then you open them and they're all blurry because people are shitty photographers. So it's like, you kind of have to figure out, like, then you have to go in and you have to start deleting the bad images, or like, you have to find like, is there like a better way to search a thing to get high quality images, like those sort of things. So it's really about techniques in which to find these pieces of data. So it's like, can I find as many images as I need? Can I find them in a high quality? And then it's like this question of diversity, which is like, if I can only find, let's say, I don't know, let's say you're into birds and you really want a specific type of bird and you can only find 500 of them. Then it's like, can I find 500 of a similar bird type and like blend those two together? Or like, the truth is you could do it with all sorts of different birds. But then it's like, do I want them only in profile view? Do I want them in every view possible? Like, each of those is going to change the output, and it's going to change the output in ways you might not expect. So like, that's the challenge. Is like, sometimes what I recommend doing is like, generate 3 data sets, one that's really tight and one that's like looser and one that's really loose. And then if you have enough money and you're willing to like spend some time testing all 3 and seeing what you get out of each of those. It's all trial and error. And like, I've learned a lot of stuff while doing multiple models, but it's still every model is a different thing. And there's some examples in the previous class of people training on different types of stuff. One guy's really into comic books, so he had just a whole data set of comic books, and he got some really interesting results. It's never redraws the comic exactly. It just makes it very noisy, but like, the colors are always there. Or like, he was training on X-Men and you could like tell who Wolverine was. Like, or like Wolverine's space was like this weird destroyed image, but it was like that yellow and blue of his body, and it, like, you could totally see it, but it just was very weird. So like, each of these, you'll get different stuff from it. And I think it's helpful to think about, like, what I think would be good is either next week or the week after, like, we could all talk about, like, what do we want to make? And you could say, like, I think I want to do this, but with this model. And the answer might be, like, actually, you shouldn't do it with that model, you should do it with this model. And here's why. And that's sort of why, like, that's hopefully why I'm here, is to help, like, guide you in a direction where I think you're going to get a better result from this, but, like, we could try it each way. Yeah. Cool. Okay, I'll walk through Runway if people want to stick around. If you have to leave at 9, feel free to walk out. Also, if you have to leave at any time, you can just do it. I'm not going to be upset.